This is the experiment number 7, that is the design and LED transreceiver circuit. And here this is the experimental circuit. Here the function generator, and this one is the LED, and this one the photo transistor, the photodiode you can use as a detector, and this is simply the integrator circuit. Okay, this is the op-amp, 10 kilo ohm resistance, 0.1 microfarad capacitor, and this one the 10 kilo ohm resistance and 100 ohm resistance. So go for the, this is the experimental circuit. Okay, this is the op-amp resistance capacitor like this. This one is the LED, and this is the photo transistor. Here first we make the circuit, and then instead of photo detector diode we use here the photo transistor, and the positive terminal is the collector. Here this one, the positive terminal of the photo transistor, this is the collector. Actually here instead of photodiode we use a photo transistor, collector as the positive terminal, and emitter is grounded. This one is the emitter is grounded, and the base is open. This is the LED, and this one the photo transistor. This the photo transistor emitter, this is work as a ground, and this is the collector. This one terminal, this goes to the 100 kilo ohm resistance and the 100 ohm resistance, 10 kilo ohm resistance and the 100 ohm resistance. And this is the integrator circuit using the op-amp, and for op-amp this is the plus minus 12 volt, plus 12 volt and minus 12 volt, two power supply, the positive power supply we use, plus and minus, and this is the 5 volt supply. And the circuit, please go to the circuit, and this is the 5 volt supply, that is go to the 10 kilo ohm resistance. So this 5 volt supply from here, this is the 5 volt supply, and the positive terminal, this goes to the this one, the 10 kilo ohm resistance. This one, this is connected to this one, this is the 10 kilo ohm resistance. Now I start the experiment. We on the function generator, these things, and this is the LED close, and we take the reading. First of all we vary, I am varying the frequency of the input signal. We use the input signal, that is the square signal as the input, and we vary the input signal frequency, and then we get the output signal, and just I read out these things. This is the input, this is the input signal. Okay, this one, this is the square wave input signal, and this the frequency is 0.43. now it is 0.43, and this one is the output signal, that's we get from the pin number 6, that is almost the triangular wave, because it is a integrator circuit. And now I just increase the value of the frequency. First of all, that is the value of the frequency, it is 0.43. Now I start from 0.43, and then we get the output voltage. It is near about 80 millivolt. Okay, it is near about 80 millivolt, and then we change the frequency. Okay, now it is near about 0.47. this is the 0.47, and this is about 72 millivolt, and then we vary 0.5, it's 0.5, and then it's about 68 millivolt. Okay, then it's about 0.6362, and it is 63 millivolt, and like this, and you can take another number of set of frequency, and this is the output voltage. So when the frequency is increased, then the output voltage is decreased. Okay, this is the table number 1, that is the frequency, input frequency versus the output voltage. This is in millivolt. Yes, this is in kilohertz, 0.43 kilohertz, and this is in millivolt. Okay. Now I start. Now I vary the distance between these two. This is the LED, and this one the photo detector. Please see this arrow that if we vary the distance, then the signal amplitude is decreases, and now I take a set of reading. Okay. Now start. This is the distance. It's equal to almost 3 centimeter, and we take the reading for the 3 centimeter. Okay. This is the distance, 3 centimeter, and its corresponding output voltage, that is, okay, it is 17 millivolt. Okay, like this. And now I deduce the distance. This is the 2 centimeter, and for 2 centimeter, and this is almost about 25 millivolt. Now I reduce. This is almost about 1 centimeter. Okay. This is almost about 1 centimeter. Please see, there is a huge difference. Now this is the 1 centimeter, and for the 1 centimeter the reading is the 40 millivolt. Okay, and you can take the another set of readings for this, and you need to draw a graph between the VPP and the F mod, that is about the that is for the first table. And how to look like this? This is the input frequency, and that one is the output voltage. And how it look like? Input frequency, if we increase the input frequency, then the output voltage is decreases. So it looks like this one. So this is the rough graph for the frequency versus output voltage. So this is all about this experiment. Okay.